Yeah, hi friends, my name is Chandan and welcome back to my channel Energy Environment Education. Friends, this is the third part of the chapter Electric Motors of BW Book 3. So basically I have already made two videos, the first part and second part, part A and part B of this chapter. This is the third and the last part. Uh, if you have missed the first two parts, you can go through. I will share the link in the comment box. You may go through of the first and second part and then you can come back to third part. So these three videos will be important for you to understand if you're preparing for the examination this year, I mean energy manager exam or energy auditor exam, if you're going to take this year or coming years. So in the first part, basically I started with the introduction part about the motors. Then also I discussed about the type of motors, the characteristics of motors, application of motors, and finally the advantages of motors. So these things were discussed by me in the first video, part A. So you may go through the video first. In the second part, I have discussed about the DC motors and the difference between the AC and DC motors, motor efficiency, slip, what is slip all about, different, major numericals and the important formulas related to motors. Those things also I have discussed. Then energy efficiency of opportunities and different losses in motors and how to mitigate or reduce those losses. Those things I have discussed in the part B, friends. So first part and second part, part A and part B are very important for you to understand, and it's a very important chapter as far as the exams is concerned because number of questions you'll find from this part of chapter. Basically, the numerical based questions will be number of them. Short answer type questions also will be asked from this part of the chapter for the this chapter. Also, you'll see that objective questions are also the number of questions are asked from this part of the chapter, friends. So basically this chapter is very important for you to understand, and numericals can be of different types, can be of short numericals which will be asked in any objective, which will be only formula based, or may not be short type, maybe a long answer also you'll get some numericals where these formulas will be applicable. So you will have to memorize all those formulas, keep in mind, and these formulas can help you to answer a number of numericals in different ways, friends. So short answer type questions, numerical based questions, long answer type questions with numericals, and also the objective questions can be asked from this part in this chapter, friends. So it's very important chapter as far as the examination is concerned. So let's start the video first. I hope this video will help you to prepare for your examinations, and I have tried to simplify all the important points from the chapter in the first part also, second part also, and this is the third and final part. One of the important points which is maybe which may help you to prepare your examination. Also, the important questions that have come earlier in the examination and which are going to come in the exam. Those things only I have discussed, friends. So I hope this will help. This video will help you anyhow to prepare for your examination. And let's see. Let's start the video, friends. Now. Now, as far as the content is concerned, friends, I'm going to start with the effect of voltage unbalance on motor performance. This is the first part that I'm going to start with, and also I'm going to deal with the common causes of voltage unbalance. Those things I'm going to discuss. Motor loading will be another important point here. Motor load survey methodology will also be a point here, which can be very useful for you to understand, and which is a very important part as far as examination is concerned. Reminding effects of energy efficiency is another part which is very important, and a lot of questions have come from this part of chapter also, friends. So you need to understand this thing also very important for your examination. And speed control of AC induction motors, those things also I'm going to discuss here. What is VFD all about, what is VFD soft starter is all about, those things also I'm going to discuss here in this particular video, friends. So this video is very important as far as examination is concerned. Part A, part B, if you have missed, please go through those videos also. And also this video is important as far as examination is concerned, friends. And before I proceed, I would again request you to please subscribe my video if not yet done. This will boost my morale to make more such videos. I'm making videos for you, friends, and it's really free for you. And you may be going to some other institutes, and maybe they may be charging you some amount for that, but I'm just making videos and publishing it only free of cost for you to understand. Maybe it will help you to prepare for your examinations, friends. So just only one request from my side, if not yet, please to subscribe my videos, and so that I can get more, boost my morale, and I mean make more such videos in coming days, friends, for you. Let's now start with the first part, friends. So as far as the effect of voltage and balance on motor performance is concerned, friends, so you may be asked in two ways or two to three ways this type of questions. Basically, they may ask you straight away to explain in brief with an example of how the what is the effect of voltage and balance on the motor performance. So this straight away question will be asked to you. Also, they may ask you to calculate the voltage and balance. Uh, so they may ask you in different ways the same question. So first of all, like suppose when they ask you to explain the effect of voltage and balance on motor performance with an example. So this is the example here, friend. Like suppose when the percent unbalancing voltage is increased, that this leads to increasing the unbalancing current also, and also increases the temperature of the motor. So if you see the parameters given here, like suppose if it is 0.30, at that time the current unbalanced percent is 0.4 and temperature is 0. Once it is increased to 2.30, the voltage unbalance, likewise the unbalancing current also increases to 17.7, and the temperature of the motor increases to 30 degrees centigrade. And likewise when the voltage unbalance is increased to 5.40, similarly the unbalancing current also increases to 40.0 and the temperature rise to 40. So this shows that as the voltage unbalance increases, the current unbalance also increases, and this leads to the effect of rising temperature in the motor. This is the one example which you may give while explaining the explain the voltage imbalance or motor performance effect. And second thing is the to calculate the voltage unbalance, friends. So they may give you the line voltage, like suppose RYB, RYYB by B are the three phase voltage they have given, like suppose VAB is 410, VBC is 417, and VCA is 408. So these are three voltages they have given you, and they will ask you to calculate the voltage unbalance. So in this case, you need to understand this, and you need to also learn the formula of calculation of the voltage imbalance. This formula will be very useful for you to calculate the voltage imbalance currents. So voltage imbalance can be found in this way, like suppose 417 minus 411.7. The 411.7 is the mean voltage unbalance. So first of all, you need to calculate the mean voltage imbalance. Once you calculate, like suppose in this case, the mean voltage imbalance is calculated as 410 plus 417 plus 408 divided by 3. It is the 411.7. The 411.7 is the mean voltage. Once you calculate the mean voltage, then you subtract it from the uh, highest voltage, that is 417 minus 411.7, and divide by the mean voltage into 100. So you get 1.29%. So this is the voltage unbalance, friends. So in this way, you need to calculate the voltage unbalance. So they will be providing you the three voltages, VAB, VVC, and VCA, and then they will ask you to calculate the voltage unbalance. So these two questions are very important for you to understand. This formula also is very important. It's a very simple formula, but still it's important for you to understand as far as the exam is concerned, friends. And now the common causes of voltage imbalance. Why the voltage imbalance takes place. So these are some of the points that you should remember. At least five of them. They may ask you more than five also, but at least five of them you must remember the different causes of voltage imbalance. So first of all, it is recommended that the voltage imbalance at the motor terminals need not exceed 1%. This is a very important point and can be asked as an objective type questions. What is the percentage, maximum percentage to which the voltage imbalance should be not be exceeded. So this is the important question for you in that way also, and anything above that will lead to derating of the motor. This is also important question. What happens if it is increased above 1%? Then they may ask you this is also question. So these 2 points is very important for you. The third point is common causes of voltage imbalance. So there are number of causes here given. At least five of them you must remember, or as much as possible you can remember. That will be helpful for you to write during the examination, friends. So let's see the different causes here. So first of all is the unbalanced incoming utility supply. Second is unequal transformer tap settings. Third is a large single phase distribution transformer on the system. Fourth is open phase on the primary of a three-phase transformer on the distribution system. Faults or grounds in the power transformer. This is also important cause for the unbalanced voltage imbalance. Open delta connected transformer banks, blown fuse on a three-phase bank of power factor, improvement factor capacitors, unequal impedance, unbalanced distribution of single-phase loads such as lighting, heavy reactive single-phase loads such as builders. So out of these, whichever you feel comfortable to remember, which you think that it's easy for you to remember, only those points you will consider. You can leave some of them, but at least five of them you must remember, friends. As far as the exams are concerned, they may ask you to at least state the what is voltage imbalance all about. Then they may ask you some formula based questions also, numerical based question on the voltage imbalance. And thirdly, the different causes of volatile environments, at least five of them you must remember, or as many as possible for you to understand or remember, friends. These things are important for you as far as the examination is concerned, friends. And now the formula of motor loading. This is a very important formula to you to understand, and maybe number of questions are asked from this formula. So straight away questions also they may ask, or maybe ask in a different way in a long answer type question also, to calculate the percent motor loading. The formula is very simple. Percent loading equals to input power drawn by the motor at a resisting load divided by root 3 kV I cos phi into 100. This is a very simple formula that you may remember, and you may calculate the motor loading percent difference. So motor loading percent also equals to actual operating load of the motor, rated capacity of the motor into 100. This is a very simple formula and very important formula as far as the examination is concerned. So this by based on this formula, number of questions have been asked earlier also, and you can expect in this year also they may ask you in different ways, maybe a short answer type questions, maybe a part of long answer type questions, or maybe even formula based questions in an objective type question, friends. So this formula is very important for you to understand, and please solve number of numericals based on this formula before you go to for examination, friends. And again, the motor load survey methodology. So you may expect to have this type of questions, basically the short answer type questions, where they may ask you to explain the concept of motor load survey methodology, or the methodology of motor load survey. In that way, they will also ask you. So this type of questions are basically asked as a short answer type questions only, or a type or a part of long answer type questions. So basically, it's very simple, and I'm not going to explain you in detail here, friends, in this particular video. Basically you can go through the chapter, and this part of the chapter you can just go through, and you may understand by yourself also what is the major methodology of motor load survey. So in short, it is the sampling criteria, second is the measurement, and third is the analysis. So basically what you do while you do the load survey, first of all you do the sampling criteria, how many motors you need to select for the load survey. Second thing is you do the measurement, that is you do the actual measurement of the load, how much the load is there, whether the motor is overloaded or underloaded. Those things also you analyze there and do the analysis part. So basically this is the what the motor load survey is all about in short. So motor load on kilowatt basis and estimated energy consumption, how much the motor is consuming energy, those things you measure basically while doing the audit. Scope for improving monitoring systems, then again once you analyze it you get the idea whether the motor is functioning well or not, whether it is consuming more power than what it should have been, or if it is underloaded or if it is overloaded. Then you I mean you do the entire analysis, and then you give the improvement measures how you can improve it, whether you should remove the motor, replace the motor, or you can do any such any activity where the motor life can be increased. Those things are the basically done during the motor load survey, friends. So I'm not going to explain you in detail here. You can just refer the chapter, and number of things you can understand from the chapter only, friends. Very simply explained there. This is a very important part, friends, as far as exams are concerned. You may expect at least one question on this part of the chapter, the remaining effects of motor energy efficiency. The question basically asked is in the form of short answer type questions or a part of long answer type questions, where they may ask you to explain in brief the remaining effects of motor energy efficiency. So you just I'm not going to explain you in detail here, friends, but I'm just going to highlight you the major effect of remaining effects of on motor energy efficiency. So what happens basically is once you rewind the motor number of times, is motor energy efficiency goes on decreasing. And second effect is the once you rewind the motor, it starts consuming more and more energy, and it also impacts the bill also, energy, electrical bill. So it's more important that you buy a new motor than you stick on a rewinded motor. So we as an auditor also recommend to our client that please do not rewind motor number of times, because as you rewind the motors, it loses the efficiency, motor efficiency decreases, and this also leads to increase in the energy bills or electricity bills. So it's better to purchase a new energy efficient motor than to stick on a rewinded motors which have been rewinded number of times. This is what recommendation we give to client also, especially when we go for an energy audit. So this is the major concept that you must understand on this part of the chapter, and you may just go through the chapter. This part of chapter you may understand by yourself also. It's not very difficult to understand, so I'm not going to explain you, friends. As far as exams are concerned, this part of chapter you may expect at least one question, and as a short answer type questions or a part of long answer type questions, the rewinding effects of on the motor energy efficiency, friends. And this is a very important part, the VFD. For the variable frequency drive, you may expect to have one question in your examination number of times before. Also, this part of the chapter has come in the examination in different examinations earlier. Basically, they may ask you in different ways what is VFD all about, why VFD is important, or the need of for VFD, and the principles of VFD. These are three major questions that they may ask you on this part of chapter. So it's very important for you to understand first of all what is VFD is all about, why VFD is important, and how the VFD works, or the principle of VFD. These three questions are very important for you to understand, and so therefore only I'm going to I have just shared you a short video for you to understand, for you to watch and understand. So please go to the video, friends. This video may help you to understand what is VFD all about and how the VFD works and why there is a need of VFD, friends. So let's watch the video first, friends.
Is a VFD? Well, is a VFD? Well, it stands for variable frequency drive. They are used for running an AC motor at variable speeds, or let them ramp up their speed to give them a smooth startup. Some people simply call them drives. They work by adjusting the frequency of the motor to adjust the RPMs. To do this, a VFD will actually convert the voltage twice. First, it converts our three-phase AC to DC. This is accomplished with diodes. Then it cleans the DC with a capacitor. Next, it will convert the DC to AC. This is accomplished with transistors acting as switches. Utilizing these switches is what allows the VFD to adjust the frequency that the VFD supplies to the motor. This, in turn, controls the speed of the motor. Now, I know this is a lot of information to take in. Let me compare the internal workings of the VFD with a simple plumbing system. First, let's look at the diodes that convert the AC to DC. This operates like a check valve in a water system. A check valve, like a diode with electricity, only allows water to flow in one direction. The capacitor acts as a water filter to keep everything clean and usable. The transistors act like valves. They turn the flow on and off when needed. This allows the VFD to adjust the frequency of the motor. Now that we have an understanding of how a VFD works, let's see what they're used for. One very common use in industry is to control the speed of a water pump in a water treatment facility. A water treatment plant typically has a constant flow of water coming into the plant. However, if the water demand exiting the plant is lower than the supply entering the plant, then the operator will need to slow down the supply. This is achieved by using a VFD on the AC motor. The operator can monitor water flow and manually adjust the VFD accordingly. Another great thing about VFDs is the fact that they can be controlled with a PLC. Using basic communication protocols that have been covered in previous videos, such as RS-232 and RS-485, PLCs can monitor and control motor speeds using the VFD. This helps make a process like water treatment that much easier and more efficient. This setup can be used in any situation that would benefit from automation. Let's look back at what we now know. VFD stands for Variable Frequency Drive. They are used for controlling the speed of an AC motor. They are also used for ramping up a motor for a smooth startup, or to prevent a heavy load from straining the motor on startup. This is accomplished by adjusting the frequency delivered to the motor. A setup of an AC to DC converter, then DC to AC converter. VFDs are used throughout industry. A common example is to regulate water flow entering a water treatment plant. VFDs allow the operator to control the flow of the pump manually or automatically with a PLC. There are many different brands and features available. If you're looking at using a VFD, just be sure to do your research. I hope this
So I hope friends you must have enjoyed the video and you must have now understood what is VFD all about, why VFD is important and how the VFD works, what are different applications of VFD. So those things have been explained in the video. So I hope the video must have cleared you a lot of concepts on VFD, and this thing is very important for you to understand because in exams also you may be asked in different ways to explain VFD or to explain the principle of working of VFD or to explain the importance of VFD and or the application of VFD, how the VFD works, where the VFD is important, why the VFD is important for industries. Those different type of questions they may ask you on based on VFD friends. And the topic important for you to understand the soft starter. Why soft starter is important, what are the advantages of soft starter. Like suppose if you see the soft starter advantages, it has less mechanical stress, improves the power factor, lower maximum demand and less mechanical maintenance. These are the four important advantages of soft starter. So basically they may ask you what is soft starter all about, why soft starter is important or advantages of soft starter. So again I'm sharing one more video on soft starter, and one more important question you may be asked, that's what I'm trying to explain here through the video. That is, what is the difference between the soft starter and the VFD. So you have seen the VFD, now it is a soft starter. So both are important. They may ask you question in different ways. What is VFD all about? What is soft starter all about? Or they may ask you as to differentiate between the soft starter and the VFD. So the coming video is very important for you to understand. Earlier you saw the video where it was shown that what is VFD all about. In this video, I'm just trying to explain you what is soft starter all about and what is the basic difference between the soft starter and the VFD. What are different applications on for VFD and where the soft starter is used and where the VFD is used. Those things I explain in the coming video, friends. So please watch this video. Maybe this will clear your concept in a more better way, friends.
A soft starter is generally used in applications where there is a large inrush of current that could damage a motor, while a VFD controls and can vary the speed of a motor. In this video, we will look at the internal workings of the devices, how to determine which device you might want, and look at some applications to better understand these differences. Let's first talk about the internal workings of the two devices. A typical three-phase soft starter uses 6 thyristors or silicone-controlled rectifiers, oriented in an anti-parallel configuration to start the electric motors smoothly. A thyristor is made up of 3 parts: a logic gate, a cathode, and anode. When an internal pulse is applied to the gate, it allows current to flow from anode to cathode, which then sends current out to our motor. When the internal pulses do not apply to the gate, the SCRs are in the off state, and therefore they restrict the current to the motor. These internal pulses limit the applied voltage to the motor, slowing down inrush current. The pulses are sent based on ramp time, so the current will be slowly applied to the motor. The motor, attached to the soft starter, will start up at a nice smooth current and top out at the preset maximum speed. The motor will stay at that speed until we stop the motor, where the soft starter will ramp down the motor in a very similar way as the ramp up. VFDs have 3 main components: a rectifier, a filter, and an inverter. The rectifier acts like diodes, taking the incoming AC voltage and changes it to DC voltage. Next, the filter uses capacitors to clean the DC voltage, making it a smoother incoming power. Finally, the inverter uses transistors to convert the DC voltage and sends the motor a frequency in hertz. This frequency drives the motor to a specific RPM. We can set the ramp up and down times just like in a soft starter. From what we just covered, we can see that a VFD is basically a soft starter with speed control. So how do we know which device is needed for our application? The decision on which device you choose comes down to how much control your application requires. If your application requires a large inrush of current but does not require speed control, then a soft starter is the best option. If speed control is required, then a VFD is a must. Also, the price can be a determining factor in a lot of real-world applications. Since a soft starter has fewer control features, the price is lower than a VFD. And finally, if the size of our device is a determining factor, soft starters are generally smaller than most of the VFDs. Let's look at some real-world applications to help us see the difference between a VFD and a soft starter. The first application will be a wastewater pump. A water treatment plant typically has a constant flow of water coming into the plant. Let's assume the demand for water exiting the plant is constant with the supply entering the plant. Which device would be the best option? That's right, a soft starter would be a great choice, because in this application, when starting the water pump, there would be a large inrush of current on our motor that our soft starter could handle and gradually ramp up the pump. Since the demand for water exiting the plant is the same as supply into the plant, the speed of our pump would not vary. However, if the demand for water exiting the plant raises or lowers, we would want to vary our speed, making a VFD a better choice for the application. The next application we will look at is a cooling fan. In this scenario, a cooling fan will turn on when the plant air temperature hits a high temperature set point. Once the set point is reached, the cooling fan will slow down to maintain the air temperature unless it drops below a low temperature set point, where it will shut off. However, if the temperature continues to rise and pass the high temperature set point, the fan will need to move faster. Which device would work best in this situation? That's right, a VFD would be better than a soft starter, because the speed of the fan will need to vary. If our scenario was only turning the fan on or off based on temperature and not changing the speed, then a soft starter would be a better option. In closing, a VFD and a soft starter can do similar functions when it comes to ramp up or down a motor. The main difference between the two is a VFD can vary the speed of a motor, while a soft starter only controls the starting and stopping of that motor. When faced with an application, price and size are in the favor of a soft starter. A VFD is the better choice if speed control is required. The good news is that if an existing application has a soft starter in place and speed control is later determined to be a requirement, a VFD can easily replace a soft starter.
And finally, the star leveling of energy efficient induction motors. I'm not going to explain you friends again this part of chapter, but it is very important as far as the short essay type questions is concerned, or maybe some objective type questions are concerned. So you may expect some questions from this part also. Earlier also in different examinations in different years, some questions have come from this part of chapter, and maybe this year also you may expect some questions from this part of the chapter in different ways, friends. So please don't skip this part. I'm not going to explain you here in this particular video, but again I would request you to go through the chapter and to just go through this part of chapter. This is very important as far as exams is concerned. So I hope the videos on the motor may help you in some way or the other to prepare your exams, friends. And I have tried to only highlight the important formulas, important parts, or important questions of the chapter which are relevant to examination concerned of energy auditor and energy measure examination concerned. So I hope these are very simply explained by me, and I hope this will help you to prepare your exams in a better way. So that's all for today, friends, and I will be again uh, submitting you. I mean, again I will be posting a new video in coming days, friends. So please be in touch. If you have any queries, you may ask me. For any doubts, if you have, you may contact me in some way or the other. Like suppose, so if you may contact me on my email ID, friends. This is my email ID, basically chandansudeep07@gmail.com. This is my email ID. You may write your inputs if you have any feedbacks on the content, or if you have any suggestions for me on the content concerned, or if you want to ask me something, if you have any query on the examination point of view, something if you want to ask me, you can straight away contact me on this email ID, friends. Also, this is my mobile number 9354095167. You can call me on this number if you have some queries, if you want to ask me something as far as the examination is concerned. Also, I have a website techminister.com. You can just Google it and go through the website, and some blogs are posted there. You can just go through the blogs, and this is the way we can connect with each other. And please do subscribe my channel, friends, if not yet done. as requested earlier also in the earlier part of the video, that I am not charging anything as such for making these videos. I am making the video free of cost for you friends. Only the one request from my side is to subscribe this channel. That's what I requesting you friends. And you maybe going to some institutes or somewhere, you may be paying some amounts for that, and I'm just posting you free of cost. This is one effort to prepare you for your examinations as best as possible from my side. So only request from my side from friends that you please subscribe my channel. This will boost my morale, and maybe it will help me to prepare more videos, such videos in coming days friends. Also please press the bell icon such that once I post a new video, you may get the notification, because every day or in 2 days or 3 days I'm going to post a new video on different topics related to exam. Also few important tips also I'm going to post. Also I have posted earlier also, and I'm also going to post more such videos based on basically tips to prepare you for your examinations. So please press the bell icon so that you get the notification as soon as I post a new video in coming days friends. And also please share these videos among your friends, colleagues, whoever you think these videos are very important to them also for their exams and preparation for this year or in coming years. So please do subscribe my channel, press the bell icon, and also please share these videos among your friends and colleagues. So that's all for today friends, and we'll be meeting on a new video soon. Uh, that's all friends.